Digital electronic signboards are sometimes used as giant television screens or to post written messages. They come in different sizes, from a few meters all the way up to several hundreds of square meters. The creation of a sign starts with plans drawn by engineers and architects. Hundreds of plans are created by computer, among other methods, and require between 2 days or even a month of work. Millions of tiny lights, or light-emitting diodes called elements, make up the screen's surface. These elements are made of germanium, gallium nitrate, and silicon semiconductors covered with plastic. These elements have to be placed so as to form a matrix. Each of the 20 machines at this plant can install and solder 1,500 elements an hour. Lighting up an element requires only 10 to 20 milliamperes, and they last for about 150,000 hours. All the wires are placed behind the matrix and the different electrical connections. This conceals everything behind the sign and shelters it from the weather. Depending upon the distance from which the sign will be seen, spaces between the elements vary from 2.5 millimeters to several centimeters. A workman now makes the electrical connections. The wires have to be solidly connected to resist shaking caused by movement of the signboard. The matrices must operate together and require controllers which send information from one to the other. Thus, each group controls its own image. Each matrix has to be electrically powered and integrated to its own 5-volt element illuminating connector. Sometimes the matrices are made in 2 pieces, one supporting the elements and the other having the components. In this case, it simply requires 2 cards to establish the contact. Now they connect the information cable, which lights up and extinguishes the elements. Each matrix has 2 connectors, one which supplies the electric current and the other which carries the sign's information. Here they verify the functioning of each matrix. Then they can begin to join matrices together to construct the signboard. We see here all the colors assembled as they will be on the screen. The boards are sometimes installed outside and are thus vulnerable to the weather. That's why they put on this rubber strip which waterproofs it. The matrices are now assembled together. Then 10 matrices are joined to make up a module. At this stage, they insert the signboard conductor. Then the wires are connected. These wires transmit electric current and all the information relating to the sign. The elements require a very low voltage current, about 5 volts. Each module is then provided with its own converter to maintain a steady voltage. Then all the modules are assembled in the signboard support, and the many electrical connections linking the different modules are made. This gigantic signboard is a composition of 35 modules and 12 matrices. The signboard is almost finished. They now check the color, the luminosity, and the resolution of the screen. The signboard is made of 120,000 electrical light diodes and took nearly 3 months of work. Each year, this company constructs hundreds of digital signboards requiring about 100 million lighting elements. An electronic circuit board is a computer component which can produce spectacularly realistic scenes. Animating this particular 3-dimensional graphic took 4 months of work by artists and programmers with the aid of a G400 graphic processor by Matrox. A printed circuit board can be compared to a building composed of fiberglass floors, copper passageways, and stairs that link the floors between them. Cards are assembled with two technologies, surface wiring and wiring through the card. The components are placed into the holes and soldered into place. A stencil is used to apply soldering paste onto the card. This paste will solder the surface components. Here they place the stencil into the printing unit. It is through these holes that the soldering paste will run. The machine spreads the soldering paste, which contains, among other elements, a tin-lead alloy. The printing blades go into action. They spread the soldering paste on the stencil. This paste runs through the stencil holes and covers the metallic surfaces of the printed circuit board, which will establish the electric current. Here's the difference between an unprinted card and another printed one. The unprinted card surface is much more shiny. Now they're going to install the surface wiring elements. They are automatically positioned by this rapid placement machine. About 36,000 components are installed per hour, making it about 10 a second. This incredibly sophisticated machine is equipped with a viewing camera which verifies the alignment and dimensions of each part before installation. It unerringly positions the part at the exact spot. Another machine, slightly less precise than the previous one, installs parts where the space between two placement points is less than 0.5 millimeters. It can install 8,000 parts in 60 minutes. The card continues on its way toward the oven, which accomplishes an essential operation. Once the parts are secured, the card goes into a convection oven where the heat will solder the parts to the card. Different circuit connectors through the card are inserted into their respective holes. This operation requires great dexterity and is entirely done by hand. Then the metallic placement points need to be soldered to this card. The soldering of the circuit components through the card is done with a bath of molten tin-lead alloy at a temperature of 240 degrees centigrade. Now everything is installed. They have to do an initial electrical test. The card is placed on a bed of electrified pegs. These pegs make contact with the card's connecting points, allowing them to check for short circuits or open circuits in the card. And then a final test, a computer-aided operating test to see if the card is functioning perfectly. This company fabricates 200 models of different circuit boards and produces about 4,000 cards each week.